Close your eyes. Feel the chair beneath you, the texture of your clothes against your skin. Solid, real, undeniable, right? This is the reality we experience every day, a world of tangible objects and direct contact. We reach out, our fingers brush against a surface, and we feel, or do we? What if this feeling of touch, this fundamental sensation, is actually an illusion? Our senses, while remarkable, are limited. We perceive a world of solidity, unaware of the strange microscopic dance happening just beyond our perception. The truth, as revealed by science, is far stranger than anything we could have imagined. To understand why you've never actually touched anything, we need to journey into the heart of matter, into the realm of atoms and the bizarre laws that govern them. Imagine shrinking down, smaller and smaller, past the level of cells and molecules, until you reach the realm of atoms. This journey takes us into a world that is invisible to the naked eye, a world where the rules of physics as we know them start to change. This is where the true nature of reality begins to unravel. Here in this microscopic universe, we encounter the building blocks of everything around us. Atoms, the fundamental building blocks of everything we see and feel, are mostly empty space. Despite their tiny size, they are incredibly complex and fascinating. Imagine a vast cathedral with a single grain of sand at its center, representing the nucleus of an atom. This analogy helps us grasp just how much empty space there is within an atom. The rest, the vast expanse, is empty space populated by a few even tinier particles, electrons, flitting about like ghosts in the void. These electrons move so quickly that they create an illusion of solidity. Now imagine two of these mostly empty cathedrals approaching each other. What happens when they come close? You might expect them to pass right through one another, right? Given all that empty space, it seems logical. After all, they're mostly empty space. But the reality is far more intriguing. But something remarkable happens, something that prevents us from falling through the earth and dictates the very existence of our solid world. This phenomenon is due to the electromagnetic forces that cause atoms to repel each other, creating the solidity we experience every day. Atoms, despite being mostly empty space, have boundaries. These boundaries aren't hard edges like the walls of our imaginary cathedral, but rather force fields, invisible barriers generated by the interactions between electrons. Electrons, those tiny specks flitting around the nucleus, carry a negative charge. Like charges repel each other, and this repulsion is what gives atoms their structure. When two atoms get close, their electron clouds, those fuzzy regions where electrons are most likely to be found, begin to overlap. This overlap creates a powerful repulsive force, far stronger than you might expect given the tiny scale. It's this force, this electromagnetic repulsion, that prevents atoms from passing through each other and gives rise to the illusion of solidity. The concept of electron clouds is crucial to understanding why we've never truly touched anything. These clouds represent regions where electrons are likely to be found, but their exact positions are never certain. Electrons don't orbit the nucleus like planets around a star, following predictable paths. Instead, they move in a more complex and less predictable manner. Instead, they exist in a cloud of probability, a region of space where they're most likely to be found. This cloud is not static, it is a dynamic and ever-changing entity. These clouds are constantly shifting and changing, creating a dynamic and fluctuating boundary around each atom. This boundary is what defines the space an atom occupies. When you touch an object, what you're actually feeling is the combined repulsive force of countless electron clouds pushing back against your own. This force is a fundamental aspect of how we interact with the physical world. The closer the atoms, the stronger the repulsion. This repulsive force increases exponentially as the distance between atoms decreases. This force is what gives objects their texture, their hardness or softness. The way electron clouds interact determines whether a material feels smooth or rough to the touch. It's the reason you can feel the smooth surface of a glass or the rough texture of sandpaper. These sensations are all due to the intricate dance of electron clouds at the atomic level. Think about that for a moment. The very act of touch, Something we perceive as direct and intimate is actually mediated by invisible forces acting at a distance. We never truly make contact with anything. Instead, we experience a constant dance of repulsion, a subtle interplay of electromagnetic fields. This might seem counterintuitive, even unsettling. We're so accustomed to the illusion of solidity, to the belief that we can reach out and touch the world around us. But the truth, as revealed by science, is far more nuanced and awe-inspiring. So, the next time you reach out to touch something, remember this. You're not actually making contact. You're always hovering, suspended just above the surface by an invisible force field. The feeling of touch, that sense of connection, is an illusion, a testament to the power of our senses to construct a coherent reality from the bizarre and wonderful rules of the quantum world. The world, it turns out, is far stranger than it appears, and the universe within, the microscopic realm of atoms and forces, is just as vast and mysterious as the cosmos above. This understanding, this knowledge that we've never truly touched anything, shouldn't make us feel disconnected from the world. Instead, it should deepen our connection to the universe, making us realize that we are part of a grand, intricate dance of particles and forces. On the contrary, it should fill us with a sense of wonder and awe. The night sky, with its countless stars and galaxies, becomes a reminder of the vastness and beauty of the cosmos. It reminds us that reality is far more complex and intricate than our limited senses can perceive. The microscopic world, teeming with life and activity, is a testament to the hidden wonders that lie beneath the surface. It invites us to question our assumptions, to delve deeper into the mysteries of the universe both within and around us. Every discovery, every new piece of knowledge adds to the tapestry of our understanding. The next time you feel the warmth of the sun on your skin or the coolness of water on your fingertips, remember, these sensations are the result of complex interactions at the atomic level. You're not experiencing direct contact, but the subtle dance of forces, the push and pull of electromagnetic fields that govern the interactions between atoms, the intricate interplay of energy and matter that makes up the fabric of our universe. This dance is what gives rise to the physical sensations we experience every day. And that in itself is a truly remarkable thing. It is a reminder of the beauty and complexity of the universe and our place within it.